One car was harmed in the making of this video.
The history of genetic screening dates all the way back to 1865 with Mendel's experiments of pea plants. This gets the ball rolling with the creation of Mendelian genetics. Skip a few decades and we already see people such as English physician Archibald Garrod linking diseases to our genes. Garrod is able to correlate Alcopternia as a recessive Mendelian trait. For almost half a century, we see great development in our understanding of the genetic model, with large breaks in science such as Watson and Crick's double helix model and the definition of the number of chromosomes in humans. After this time, we see another few uses of genetic testing arise, such as Jerome Lejeune's discovery that Down syndrome is caused by change in the chromosome count, and the beginning of screening babies. This was developed by Dr. Robert Guthrie and checked infants for phenylketonuria. In the 1960s, we see another period of learning about the genome. We discover that mRNA has the job of creating proteins. We decode the nucleic acid alphabet, and we begin using restriction enzymes to cut DNA. This helps with mapping the genome, which we see a lot of in the future. In 1975, a man named Frederick Sanger comes up with his new hip way of rapidly sequencing DNA, and it's called the Sanger method, and it's used. Walter Gabler comes up with his own method to do the same thing, but his method is lame, and no one uses it. 1976 comes around, and so does Genentech. This business is the first to genetically engineer and keeps itself at the forefront of its field. Around 1982, it becomes a fad among scientists to submit DNA sequence data to the NIH Public GenBank. Soon after, we successfully map our first disease, and it's on chromosome 4. An incredible landmark for genetic screening takes place in 1986 when a kid named Richard Buckland is exonerated for the rape and murder of 2 women. This is the first investigation using genetic screening and leads the way to the use of forensic. They end up identifying the killer as Colin Pitchfork. In 1990, we set up a 15-year plan to map the human genome. In 1995, America creates laws that will protect workers from genetic discrimination. The next 8 years are packed full of sequencing and mapping. We start with E. coli and a form of tuberculosis. Bacteria are easy though, and we want a challenge, so we map out the entire roundworm genome. And finally, in 2002, the mouse genome is completely mapped, and close behind is the human genome. These two monumental events give us a basis to compare DNA when screening patients for any traits, whether they be diseases or merely aesthetic features.
There are 7 main types of genetic testing. The first is newborn testing, which is when a newborn is tested just after birth to diagnose genetic disorders that can be easily treated early in life. Diagnostic testing is used to confirm a diagnosis of some disorder based on previously observed symptoms. Carrier testing identifies if an individual is a carrier for a disease, like heterozygous. If both parents are tested, this test can be used to see if a child between them has a chance to get a disorder. Prenatal testing detects changes in fetal DNA pre-birth. It is offered during pregnancy if there is an increased risk that the baby will have a disorder. It usually isn't very accurate, but it can be helpful to determine if a child will have some disease. Pre-implantation testing is used in in-vitro fertilization fetuses, where some embryonic cells are tested for genetic changes and only embryos without those changes are implanted. Predictive and pre-symptomatic testing can determine if someone is going to have some condition before it shows up. It tests for certain mutations that can lead to a higher risk of cancer or some other disease. Forensic testing compares the subject's DNA to evidence to find who committed a crime.
I was diagnosed in 1983 and had radiation treatment for 6 weeks and chemotherapy for 6 months. I decided to receive genetic testing primarily for my daughter because I was concerned that she might develop breast cancer as well. I did not have the gene. They all went, yay God.
So I had genetic testing for hereditary colorectal cancer. I went to the doctor and I ended up having a colonoscopy. And because of my age and the number of polyps that they found, they thought that it would behoove me to have this testing to see if I had a genetic indication that would lead to colon cancer later in life. So the results were that I do have a mutation. So I have a lifetime chance of getting it between 70 and 100%. And that will increase the closer I get to 55. So it was beneficial for me to know, so that if anything that I can do to prevent that, which is why I get yearly colonoscopies. Yay team. The doctor that I was seeing actually recommended that I have my colon removed. And I wasn't gonna do that. I said, if you can give me a newer, better one, we could talk about that, but that doesn't happen when they take out your colon. So I decided to do my own research online, and I've done some things, kind of holistic treatments. I've done some things dietary-wise, and I'm in a good place. Personally, I don't have any children, so I can't pass this on genetically to anybody, but it caused me to have, heart-to-heart with my brother, who isn't ready to go down that road yet, which I understand. But he has a son, and I would love for him to have testing so that it's something that he could find, and we can make sure that the little guy that's 11 does everything that he can to not have this.
As the development and use of genetic screening in today's world increases, the future effects have become more important to consider. Healthcare and life insurance rates may increase due to companies' ability to get genetic information. The 1996 survey of individuals at risk of developing a genetic condition identified more than 200 cases of genetic discrimination among the 917 people who responded, involving discrimination by insurance companies, employers, or other organizations that use genetic information. However, this also brings up the question that increased rate of diagnosis could lead to shorter hospital stays and decreases in medical care costs through the use of genetic screens, rather than an increase. Genetic screening could lead to a decrease in birth rates of children with a chance of disease, but can prenatal tests be counted on as definite information? A recent study showed that 6.2% of women who received test results showing their fetus at a high risk for a condition terminated their pregnancies without a diagnostic test. Yet these prenatal tests that are touted as being 99% accurate are not as thorough as diagnostic testing. The screens are not subject to approval by the FDA, and because of a loophole, the companies operate free of agency oversight and the kind of analysis that would validate their accuracy claims. Genetic screening is improving the ability to diagnose diseases and give early-on treatment to improve and prolong the lives of many. Gene therapy is a solution to the inability to make proteins or digest substances using this genetic information. The new field of genetic counseling is giving insight into raising a child with medical issues to unknowing parents. However, gene patents are inhibiting testing because of cross-patent issues. No approval means no ability to use information. Testing remains limited until the future broad licensing is available and additional tests can be run. So in the future, is it ethical to keep these patents and make complete diagnosis more difficult? Or if you have a genetic defect, should your life be different because of it?